Hello students, welcome to Educate. Today we are going to continue with the concept of potential energy, physics of class 11, chapter number 5. So we have already studied that kinetic energy is given by half mv square, and work energy theorem says work done equal to change in kinetic energy. Here we are going to study potential energy. So PE is given by mgh. Now here one important concept: force is given as negative gradient of potential energy. Here, so what is important here? Symbol V is used for potential energy. Later on we will use symbol like U, so don't get confused. Now there are two types of forces. One is conservative force, that is path independent force, and another is non-conservative force, that will be path dependent. So gravitational force, if you consider, gravitational force, so it is path independent. Example, suppose work done, if you want to calculate in this case, work done against gravity, suppose this is 2 meter, this is 2 meter, this is 2 meter, and and suppose mass is say 2 kg, so W equal to mgh, which will be potential energy. So mass is given as 2 kg and h, total height 2 plus 2 plus 2, 6 into g is 10 joule. Directly if person starts moving from here, it goes to 6 meter. So still work done will be same. So such force is called conservative force. But force that depends on path, that is called non-conservative, like frictional force, viscous force. So about these forces we will study later. Now we are going to see energy conservation. So change in kinetic energy, change in Ke. So delta K, let's denote it, is given by work done, work energy theorem. So we can write F into delta X. But we have studied that force, if it is conservative, so it can be given as dV upon dx, negative gradient of potential energy. We will do numerical based on it. Here we have to differentiate the potential energy with respect to x. So I will show you how to do that. So F equal to minus dV upon dx, or you can also write F equal to minus delta V divided by delta x. So if you cross multiply, what do you get? F delta x equal to minus delta V. You write this value here. So delta K equal to minus delta V. So you take this to this side, delta K plus delta V is equal to 0, or delta you can take common, K plus V equal to 0. This is kinetic energy, this is potential energy. So change in kinetic and potential energy is constant. It means here, sorry, change in potential energy and kinetic energy is 0. It means they are constant. So this is energy conservation principle. This principle can be verified by taking an example of falling object. So suppose you are given, suppose this position A, this position B, and this position C, and there is one object here at height h, total height up to here is H. Now at this point, at point C, KE object is not moving, so K is 0, PE is just mgh. So what is total energy here? It will be sum of the two, that is mgh. So this is first case. Now when object is allowed to fall, so suppose it covers distance x, so it will acquire certain velocity. Here u is 0, suppose velocity acquired at this point is v. Now applying formula v square equal to u square plus 2as, here it will be gh. So velocity v square equal to 0 plus 2g and distance followed is x. Now at this point we have to find out what is kinetic energy. So kinetic energy can be found from here. So Ke will be half mv square, m times v square, we have got 2gx. So here 2 will cancel out, mgx. This is kinetic energy. And height above the ground is h minus x till this point. So what is potential energy? Let's write it as V. So potential energy will be mg h minus x. Now find total energy, K plus V. So what happens? mgx plus mg h minus x. So mg x and minus mgx will cancel out from here. So mgh will be left. So what you have observed here? So at this point, at point C, total energy was mgh. At point B, total energy is again mgh. Now consider the case when object reaches to point A. So at point A, height will be 0. If height is 0, then potential energy will become 0. So at A, h equal to 0. So PE, which is denoted here as V, will become 0. But since object has fallen through height h, so we can apply the formula V square. We assume that at this point velocity becomes capital V. So capital V square equal to, it started from 0, so 0 plus 2gh. Let's find out kinetic energy. So that is half mv square. We put the value 1 by 2 m times v square, that is 2gh. So mgh. So what you have observed in all three cases, you have seen that energy remains conserved. Sum of potential energy and kinetic energy is constant. So we can say that the total mechanical energy of a system is conserved if the forces doing work on it are conservative. The cases that we have studied were involving conservative forces only. We will study later on the cases of non-conservative forces where this rule does not apply. So we will study other questions based on this concept. Thank you. Team Educate.